Good day, everyone. Today I will be teaching about arithmetic sequence. Now let's define arithmetic sequence. Arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant. So let's have an example. We have 5, 7, 9, 11, 13, and 15. We need to find the difference between this sequence. So 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. 13 minus 11 is 2. 15 minus 13 is 2. As we can see, we have a constant difference of 2. And this is what we call the common difference. Let's try another example. We have 2, 4, 8, 16, and 32. Is this an arithmetic progression? Well, let's see. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. And 32 minus 16 is 16. We have 2, 4, 8, 16 as the difference of the sequence. We don't have the constant difference, so this is not an example of arithmetic progression. Let's try 3, 8, 13, 18, and 23. We have the common difference of 5. They have the same difference, so we will consider this an arithmetic sequence. So yes. The terms in the sequence are often denoted with a variable and a subscript, like a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on. All of the terms in a given sequence are written with the same variable and increasing subscripts. So, when we have a sub 1 is equal to 1 and the common difference with 2, we can write this in a recursive formula, wherein a sub n is equal to a sub n minus 1 plus the common difference. So in this case, we have a sub n is equal to a sub n minus 1 plus 2, because this is the common difference of this sequence. So let's try to find a sub 3. So let's find first a sub 2. So it's equal to a sub 2 minus 1 plus 2 is equal to a sub 1 plus 2. So we have the value of a sub 1, which is 1. So we have 1 plus 2 is equal to 3. What about a sub 3? A sub 3 is equal to a sub 3 minus 1 plus 2 is equal to a sub 2 plus 2. Wherein a sub 2 is equal to 3, so we have to add 3 plus 2 is equal to 5. In this case, we use the recursive formula to find the missing term, which is a sub 3. Now, when a sub 5 is missing, we just continue to solve using the recursive formula. So let's have a sub 4 is equal to a sub 4 minus 1 plus 2 is equal to a sub 3 plus 2. We get the value of a sub 3, which is 5. 5 plus 2 is equal to 7. Now, let's have a sub 5. A sub 5 is equal to a sub 5 minus 1 plus 2 is equal to a sub 4 plus 2. 7 plus 2 is equal to 9. So the value of a sub 5 is 9. We have another example wherein a sub 1 is equal to 0. Our common difference is 6. find the first four terms of the sequence, we need to use the recursive formula. So the recursive formula for the sequence is a sub n is equal to a sub n minus 1 plus the common difference, which is 6. So let's solve. Let's find a sub 2. A sub 2 minus 1 plus 6 is equal to a sub 1 plus 6, wherein a sub 2 is equal to 0 plus 6 is equal to 6. And now let's have a sub 3. A sub 3 minus 1 plus 6, a sub 2 plus 6 is equal to the value of a sub 2. Let's substitute 6 plus 6, and we have a sub 3 is equal to 12. Now let's try. Let's have a sub 4, which is the fourth term. We have a sub 4 minus 1 plus 6 is equal to a sub 3 plus 6. We have the value of a sub 3, which is 12 plus 6 is equal to 18. Now we have the first four terms of the sequence, which is 0, 6, 12, and 18. We can write this as 0, 6, 12, and 18. We can also use the explicit formula to get or to find the next term of an arithmetic sequence. So the explicit formula for the arithmetic sequence is written as a sub n is equal to the common difference in the number of terms plus a sub 0, wherein a sub 0 is equal to a sub 1 minus the common difference. For example, we have 2, 5, 8, 11, 14. We have to find the common difference of the sequence. And the common difference is 3. 3, 8 minus 5 is 3. Now, our a sub 1 is equal to 2. And our a sub 0 is equal to a sub 1 minus d, wherein a sub 1 is equal to 2 and our common difference is 3. So, our a sub 0 is negative 1. Substituting these values in this formula, we have a sub n is equal to our common difference times the number of terms plus the a sub 0, which is negative 1. Now we have a sub n is equal to 3n minus 1 as the explicit formula of the sequence. Now, can we find a sub 16? Let's try. So, a sub 16 is equal to 3 times 16 minus 1. So, 16 times 3 is 48 minus 1 is equal to 47. So, a sub 16 is 47. By using the explicit formula, we get a sub 16. So, let's try another one. A sub 20. A sub 20 is equal to 3 times 20 minus 1. 20 times 3 is 60 minus 1 is equal to 59. Aside from explicit and recursive formula, we also have the general formula, and I will show you the derivation of this formula. A sub 1 is equal to a sub 1. A sub 2 is equal to a sub 1 plus the common difference. A sub 3 is equal to a sub 2 plus d. A sub 4 is equal to a sub 3 plus d. We can write this as a sub 1 plus d plus d. And this, we can write this as a sub 1 plus d plus d plus d, wherein this one, a sub 3, can be written as a sub 1 plus 2d, and this can also be written as a sub 1 plus 3d, wherein we can say that a sub n is equal to a sub 1 plus n minus 1 times the common difference. So this is what we call the general formula to find the next term in the arithmetic sequence. And now we should use the general formula to solve this problem. Find the 18th term of 21, 24, 27, 30, 33 as it reaches a sub 18. So let's find the common difference. 24 minus 21 is 3. 27 minus 24 is also 3. 30 minus 27 is 3. 33 minus 30 is 3. So the common difference of the sequence is 3. So we must apply a sub n is equal to a sub 1 plus n minus 1 times t. We have a sub 18 is equal to a sub 1, and our a sub 1 is equal to 21. So 21 plus 18 minus 1 times the common difference, which is 3. So we have a sub 18 is equal to 21 plus 17 times 3. Have a sub 18 is equal to 21 plus 51, and a sub 18 is equal to 72. So in this problem, we have find a sub 19 in the arithmetic sequence, where 7 is the first term and the fifth term is 19. So we have a sub 1 is equal to 7, a sub 5 is equal to 19. We can use the general formula to solve this problem. We're finding b, so we use a sub n is equal to a sub 1 plus n minus 1 times d. We have a sub 5 is equal to a sub 1, which is 7, plus 5 minus 1 times d. So we have the value of a sub 5, which is 19. 19 is equal to 7 plus 40. So we have to transpose 40 to the left side, while 90 to the right side. So we have 4d is equal to 12, wherein the common difference is 3. Now let's find a sub 19. A sub 19 is equal to 7 plus 19 minus 1 times the common difference, which is 3. So 7 plus 18 times 3, we have 7 plus 54 is equal to 61. So a sub 19 is equal to 61. And to have a sort of review to our discussion, we have the recursive formula, which is a sub n is equal to a sub n minus 1 plus the common difference. While the explicit formula, we write that as a sub n is equal to the common difference times the number of terms plus a sub 0. And the general formula for the arithmetic sequence is a sub n is equal to a sub n plus n minus 1 times the common difference. So now let's discuss about arithmetic series. So let's define arithmetic sequence. This is the sum of arithmetic sequence. For example, we have the arithmetic sequence 21, 24, 27, 30, and 33. So this would be 21 plus 24 plus 27 plus 30 plus 33. So this is an arithmetic series. Now, arithmetic series have a formula. S sub n is equal to n over 2 times a sub 1 plus a sub n. We can apply this formula to this arithmetic series. So we have a sub 1 is equal to 21 and a sub 5 is equal to 33. Now we have to find the summation of 5, s sub 5 is equal to n over 2 times a sub 1 is 21 plus a sub n, which is a sub 5, 33. We have s sub 5 is equal to 5 over 2 times 54. We have to cancel this out. So we have 1, 27. 27 times 5 is equal to 135. So, the sum of this arithmetic sequence is 135. So, let's have an example. Here we have 5, 9, 13, and so on as it reaches 101. So, we have the missing term, which is the number of terms, and is missing. So, we must use the explicit formula. We can use that. A sub n is equal to 4n plus 1, wherein 4 is the common difference and 1 is the a sub 0. So we have 101 is equal to 4n plus 1. So we have 4n 100. So n is equal to 25. We can now solve for the sum of this arithmetic sequence. Summation 25, s sub 25 is equal to 25 over 2 times a sub 1, which is 5, plus a sub 25, which is 101. So we have sub 25 is equal to 25 over 2 times 106. We need to cancel this out. We have 53 and 1. So we have 25 times 53. So s sub 25 is equal to 1325. Now, let's go with this. We have 4, 11, 18, and so on as it reaches a sub 16. So we have the s sub 16 is equal to n, which is 16 over 2. Have 4 plus a sub 16. So a sub 16 is the missing term here. So we must use this formula. N over 2 times a sub 1 plus the formula of the general formula of the arithmetic sequence. We can use that to get a sub 16. So a sub 1 plus n minus 1 times d. And now s sub 16 is equal to 16 over 2 times 4 plus 4 plus 16. 16 minus 1 is 15 times d. S sub 16 is equal to 16 over 2, 8 plus 15. So what is the common difference of this arithmetic sequence? The common difference is 7, so we should use that. So times 7. Now we have S sub 16 is equal to 8 times 113. So S sub 16 is equal to 1188. And for today's last lesson, harmonic sequence. We can define harmonic sequence as sequence whose term is a reciprocal of the arithmetic sequence. Example. We have 2, 4, 6, 8, 10 as our arithmetic sequence. Now, when it's a harmonic sequence, must be 1/2, 1/4, 1/6, 1/8, and 1/10. Now, in solving this, we are using the formula of an arithmetic sequence. But also remember that the answer must be in the reciprocal form. So, let's have an example. Now, let's answer this problem. Find the 24th term of the harmonic sequence 1/3, 1/5, 1/7. So, let's have first the arithmetic sequence. So, we have to get the reciprocal of this. So, a sub 1 must be 3 and a sub 3 must be equal to 7. So, we have a sub 3 is equal to a sub 1 plus n minus 1 times t. So, a sub 3 is equal to 7. A sub 1 is equal to 3 plus 3 minus 1 times the common difference. So, we're finding the common difference here. D is missing. So, we have 7, 3 plus 2d, wherein we transpose, so we have 4 is equal to 2. So we have d is equal to 2. Now, what about when solving the 24th term? We're like using a sub 24 is equal to 3 a sub 1 plus 23d. So we have 3 plus 23 times 2. So we have now 49. Since this is an arithmetic sequence, we should use a sub 24. A sub 24 of the harmonic sequence must be 1 over 49. We reciprocate the value of the arithmetic sequence. This is your tutorial 101. Thank you, and I'm Genesis Arnisto from 10 Schrodinger.